Okay, let's dive in. We received some truly incredible questions from you, the kind that really stop you in your tracks, make you look up,
Absolutely. Questions about, well, pictures on Earth of alien life or even beings from other dimensions.
Yeah, exactly. And you also asked if maybe we're living in different dimension and maybe we can't see them.
Uh-huh.
And then the really big one is the universe in a big creator, that we are living inside of a big creature. Just, wow.
And these aren't just, wild guesses. Your sources show these are actually deep questions people have thought about for ages. They sit right where science, physics, and philosophy meet.
Right. So for this deep dive, we're going to use the material you sent over to really unpack these ideas. We'll look at what the science actually says.
What the sort of cutting-edge theories are suggesting.
And where things tip over into more philosophical thinking.
We'll stick close to your sources, making clear what's, hard evidence versus theoretical models or just philosophical concepts.
Okay. And let's just state this up front, based on the sources. Right now, scientifically speaking, there are no validated pictures on Earth of aliens or dimensional beings in the way you might be thinking. The sources are really clear on that.
Yes, the material definitely grounds us in that reality. It's about the scientific search and the theoretical possibilities, not unproven claims.
Got it. So think of this as a journey through what we know, what we think we might know, and the huge unknowns, all guided by the info in this stack you provided. Let's get started.
Okay, well, your question about pictures on Earth leads us nicely into the scientific search for life out there. Astrobiology, essentially.
Right, astrobiology. It's like science's attempt to answer that big question, are we alone? And the sources do stress, despite movies and stuff, there's no solid proof of ET life or visits yet.
No conclusive evidence, no. So no validated pictures in that sense.
So how do scientists look?
Well, the main methods are searching for biosignatures and technosignatures.
Biosignatures, those are like chemical clues, right? In an atmosphere somewhere.
Exactly. Chemical fingerprints. Trace gases that, might hint at life. The James Webb Space Telescope is a huge deal here.
Because it can actually analyze exoplanet atmospheres.
Yes, but your sources rightly add a note of caution. Interpreting that data is really complex. There isn't one single gas that screams life.
Yeah.
It's more subtle.
Needs careful work.
Very careful. And the sources mention future missions, too, specifically designed for this, like NASA's Habitable Worlds Observatory.
And that European life mission.
Both aiming to study Earth-like planets, looking for things like water, oxygen, methane, key indicators.
Okay, so that's the chemistry side. What about technosignatures?
That's SETI, the search for extraterrestrial intelligence, looking for signs of technology. Mostly, historically, that's meant listening for radio signals.
The famous WOW-W signal falls into that category.
It did, yeah, back in 1977, though it was likely a natural phenomenon or maybe even Earth-based interference. But SETI projects like Cosmic SETI are still active.
But the sources mention a new angle, too, something about as us.
Oh, yeah, that's really interesting. Instead of just listening, some scientists are modeling our own technological signals.
Like figuring out how our planetary radar or TV broadcasts might look from light years away.
Exactly that. What could an alien civilization, maybe with similar tech, actually detect from us? One study found our strongest signals might be detectable up to, 12,000 light years?
Wow, that's a completely different way of thinking about it. It's not just passive listening.
It's more strategic. It shows how the search itself is evolving, becoming more sophisticated, even without finding anything definitive yet.
We're getting smarter about how to look.
Precisely. And speaking of looking, closer to home, the sources highlight the spots in our own solar system with the best chance for finding life today.
You mean the ocean worlds?
That's right. Europa, Jupiter's moon, and Enceladus orbiting Saturn.
Because they have liquid water oceans under the ice.
That's the theory, yeah. Huge subsurface oceans. And crucially, they might be in contact with rocky cores or seafloors.
Which could provide chemicals and energy, like deep-sea vents on Earth.
That's the exciting possibility, a potential habitat.
Are we going there?
Well, NASA's Europa Clipper mission is heading out soon, aiming to arrive around 2031-2034 to check Europa's habitability. And there are proposals for landers, especially for Enceladus, to maybe even sample those water plumes it sprays into space.
Okay, so we're looking far away, we're looking nearby, but still nothing concrete. Which brings us to that big puzzle the sources mention, the Fermi Paradox.
Ah, yes. The paradox. It's this stark contrast, isn't it? The universe is unbelievably vast. incredibly old.
Billions of stars, probably trillions of Earth-like planets.
Right, and calculations suggest a civilization could theoretically colonize the galaxy in, say, 5 to 50 million years of blink and cosmic time. So
Where is everybody? Why the silence?
that's the core question. Why haven't we seen them, or at least found undeniable proof they exist or existed?
What are the possible answers the sources touch on?
Well, maybe there's a great filter, some incredibly hard step in the evolution of life or intelligence that almost nobody gets past.
Making intelligent life super rare.
Could be. Or maybe advanced civilizations tend to self-destruct. Or perhaps they retreat into virtual realities or something else we can't detect.
That virtual worlds idea feels like it connects to other things you asked about.
It really does. And there's another important point from the science side, highlighted in the ETH Zurich study mentioned in your sources. It's about the value of not finding life.
No results. How is finding nothing useful?
It sounds weird, but it's about making the search quantitative. If you meticulously search, say, 40 or 80 planets of a certain type with sensitive instruments and find no biosignatures.
Then you can start to put numbers on it.
Exactly. You can start to say, okay, based on this sample size and sensitivity, it seems that life like this probably exists on fewer than, say, 10 or 20% of these kinds of planets.
So it's constraining the possibilities, turning absence of evidence into a form of evidence about prevalence.
Precisely. It requires careful methods, accounting for errors, like false negatives. But it shows science trying to get a statistical handle on things, even without a positive detection.
Okay, let's circle back to a specific part of your question. Life on the moon. And that dimensional angle you mentioned.
Right. Scientifically, the sources suggest a possibility, but it's very specific. It's about microbial life.
Not moon aliens evolving there?
No, not indigenous life. It's about the potential preservation of microbes from Earth that might have gotten there, maybe via asteroid impacts or even spacecraft.
Preserved how?
In those super cold, permanently dark craters near the poles, they act like deep freezers. The idea is microbes could maybe survive dormant for decades. Organic molecules even longer.
So dormant, not active and growing.
Crucially, yes. It's about survival, preservation, not active metabolism, growth, reproduction. It's fundamentally different from the potential habitats on Europa or Enceladus. It's more like finding ancient spores, perhaps.
A cold case file, not a living ecosystem.
Good analogy. And regarding the different dimension on the moon idea,
Yeah.
the sources provide no scientific backing for that. No evidence, no theory presented there suggests life exists on the moon in some other dimension we can't see. No validated pictures of that either.
Okay. So the scientific search continues. Methods are getting smarter, but no confirmed contact or dimensional beings on the moon. That covers that part.
Right. Now, let's shift gears to that other major thread in your questions. The idea of living in different dimension. This takes us out of astrobiology and into, well, theoretical physics.
Exploring the nature of reality itself.
Exactly. We experience the world in, 3 spatial dimensions: length, width, height, plus time, space-time.
Our familiar 4D world.
But some big theories in physics, like string theory and its successor M theory, actually need more dimensions mathematically
Need them. Why?
to make the math work,
Yeah.
essentially. String theory suggests 10 dimensions total. M theory suggests 11. They're required for the theory to potentially unify gravity with quantum mechanics, the big forces. It's a theoretical requirement, not something we've directly seen.
So if they exist, where are they? Why don't we, bump into them?
The idea is compactification. Your sources mentioned the garden hose analogy, right?
Yeah, it looks 1D far away, but it's 2D up close.
Exactly. So the thought is these extra dimensions are curled up incredibly tightly. We're talking maybe 10 to the power of minus 35 meters. Unimaginably small scales.
Too small to notice.
Way too small for us to perceive directly. They're sort of the hidden, tiny structure of space-time itself where the fundamental strings of the theory might vibrate.
Okay, curled up dimensions. What's the implication of that?
Well, this is where it gets really interesting. The way these extra dimensions are curled up the specific complex shapes they form, called Calabi-Yau manifolds.
Those shapes matter.
Hugely, according to the theory. The shape determines how the strings can vibrate. And how strings vibrate determines the properties of the fundamental particles and forces we see.
So different curling shapes?
Could lead to different string vibrations,
Yeah.
different particles, different physical laws, entirely different universes, potentially.
Wow, so the hidden dimensions could allow for different realities.
That's the concept known as the string theory landscape. A vast number, maybe 10 to the power of 500 or more, possible ways for dimensions to curl up, each potentially corresponding to a universe with its own physics. It directly connects hidden dimensions to your idea of different realities.
And beings in other dimensions, is that part of the theory?
That's a big leap, much more speculative.
Yeah.
If life could exist in, say, higher dimensions, how it would interact with our 3D world is hard to imagine. Like a 3D sphere passing through a 2D flatland, maybe?
Appearing and disappearing strangely.
Perhaps. Your sources touch on the fringe ultra-terrestrial idea, beings from other dimensions, maybe shapeshifters. But it also notes that maybe 3 spatial dimensions are actually kind of special, maybe the most stable for complex structures like life to form.
Okay, so dimensions are one thing. The sources then talk about the multiverse. That sounds even bigger.
It is. The multiverse hypothesis is the idea that our entire universe is just one bubble, one instance, among potentially many others, parallel universes.
And there are different scientific reasons for thinking this might be possible.
Yes, the sources outline a few key ones. One comes from quantum mechanics, the many worlds interpretation, or MWI.
Okay, quantum mechanics. Particles being in multiple states at once. Superposition.
Exactly. MWI takes that and says, well, maybe when a measurement forces a particle into one state, all the other possibilities it could have been in actually happen.
Happen where?
In other universes. The universe literally splits or branches at every quantum decision point. Think Schrodinger's cat in MWI. There's a universe where it's alive and one where it's dead.
Infinite branching universes based on quantum choices.
That's the core idea. It's one way to try and resolve some weirdness in quantum theory by just saying everything possible does happen somewhere.
Okay, that's one. What else?
Another comes from cosmology, the study of the universe's origin and evolution. Specifically, the theory of cosmic inflation, that super rapid expansion right after the Big Bang.
How does inflation lead to multiverses?
Well, if inflation didn't stop everywhere at once, if it's eternal and still happening in some regions far beyond our observable horizon, then new bubble universes like ours could constantly be forming within that eternally inflating space.
And these bubbles could be different.
Potentially very different. They might cool down from inflation with different physical laws or constants. This could explain the fine-tuning problem why our universe seems so perfectly set up for life. If there are countless universes, maybe it's just inevitable that some, like ours, have the right settings by chance.
Makes sense statistically, I guess. Any others?
String theory offers the brain world scenario. Our universe is like a 3D membrane, a brain, floating in a higher dimensional space, the bulk.
And there could be other brains?
Yes, other parallel universes, other brains floating nearby in the bulk. Maybe they could even interact slightly, perhaps through gravity leaking between them.
Okay, and the sources also mention that really speculative one, shadow matter.
Ah, yes. That one's fascinating and speaks directly to your can't see them, they can't see us idea. It hypothesizes a whole set of particles, basically identical to ours, but interacting with our matter only through gravity.
Like a parallel universe overlaid on ours, but invisible.
Pretty much. It could form shadow stars, shadow galaxies, maybe even shadow planets and shadow life existing right alongside us, totally dark to our telescopes, only detectable by its gravitational influence.
That's mind-blowing. A whole hidden reality potentially right here.
It's highly speculative, of course, but it directly addresses that feeling of unseen presences.
And these multiverse ideas, do they connect back to the Fermi Paradox, the silence?
They offer potential explanations, yes. Maybe advanced civilizations don't disappear, but they transition. Maybe they upload themselves into virtual worlds, create their own pocket universes, or learn to access higher dimensions or parallel brains, effectively vanishing from our detection methods.
So they're not gone, just somewhere else we can't see or reach.
It's a possible, though speculative, resolution. The silence might be because they've moved beyond our kind of reality.
Okay, these are huge ideas. What are the biggest challenges for scientists with multiverse theories?
The main one, as your sources note, is testability. How do you actually prove or disprove the existence of another universe you can't directly interact with? Science relies on empirical evidence, and that's incredibly hard to get for multiverse concepts.
So lots of skepticism.
Definitely. Many scientists view it as more philosophy or metaphysics than testable science, at least for now. There are some proposed indirect tests, like looking for subtle patterns in the cosmic microwave background that might be bruises from collisions with other bubble universes, or those simulation limit tests, but they're very difficult.
Still, it's amazing that these ideas come out of trying to solve real problems in physics.
Exactly. They're not just pulled out of thin air. They emerge from trying to understand quantum gravity, inflation, string theory, the frontiers of physics.
Right. Now let's shift to the final, maybe most philosophical part of your questions. Is the universe itself a big creature we live inside, a big creator?
This takes us into some really deep philosophical territory. The idea of the universe as a living organism, sometimes called organicism, has ancient roots.
The sources mention Plato.
Yes, his idea in the Timaeus of the Cosmos as a single intelligent world animal or living being with a soul, seeing the universe not just as dead matter, but as an interconnected dynamic whole.
Like the universe itself is alive in some sense.
That's the core idea. And modern philosophy has built on this with concepts like panpsychism.
Which is?
The idea that consciousness or mind isn't just something that happens in brains, but is a fundamental property of reality itself, present everywhere in some rudimentary form.
So even an electron might have some tiny bit of consciousness.
In some versions, yes. And then there's cosmopsychism, a related idea that the cosmos as a whole is the primary conscious entity, and our individual minds are derived from that cosmic mind.
Wow. Is there any connection to science here, or is it purely philosophy?
Well, it's mostly philosophy, but some scientific theories about consciousness, like integrated information theory, IIT, from Giulio Tononi.
Okay.
IIT tries to define what consciousness is in terms of information processing and integration. It suggests that any system with a high enough level of integrated information could be conscious.
Not just brains.
It's usually not just brains.
Yeah.
While highly controversial, some proponents speculate that if the universe itself has a sufficiently complex structure of integrated information, then IIT might imply the universe could possess some form of consciousness.
So a potential, though highly speculative, scientific angle on the big creature idea. Consciousness based on information, not biology.
It offers a different lens, moving beyond a literal biological interpretation towards something based on information and structure.
Yeah.
It challenges our assumptions about where consciousness can reside.
Okay, so that's one way to think about a creator or creature. What about this simulation hypothesis? That feels like the modern tech version.
It absolutely is. The idea that our reality isn't the base reality, but a sophisticated computer simulation created by some other intelligence.
Sounds like science fiction, but the sources link it to older ideas.
Definitely. It echoes ancient ideas of reality being an illusion, like Maya in Hinduism, or Plato's cave allegory, where prisoners mistake shadows for reality, or Descartes wondering if an evil demon was deceiving him. It's an old question updated for the computer age. Konrad Zuse even talked about digital physics decades ago.
So in this model, the big creator is what? An advanced civilization running a program?
Exactly. The creator is a simulator, potentially a post-human civilization with immense computing power, and we are characters or processes running inside their simulation.
Nick Bostrom's argument comes up here in the sources.
Yes, his simulation argument isn't proof, but a logical trilemma. He argues that if civilizations tend to reach a post-human stage capable of running ancestor simulations, and if they'd be interested in doing so, and if simulated consciousness is possible, then one of three things must be true.
Okay, what are the three?
1. Civilizations almost always destroy themselves before reaching that capability. 2. They reach it but lose interest in running simulations. Or 3. We are almost certainly living in a simulation because simulated beings would vastly outnumber non-simulated ones.
And he leans towards number 3.
He argues it's statistically plausible, assuming those conditions hold, especially the big if, about whether consciousness can actually arise from computation. That's still a huge philosophical debate, the hard problem of consciousness.
Right, and the sources connect this hypothesis to our own tech advancements, which makes it feel less abstract.
That's a key point. Seeing our own rapid progress in AI, virtual reality, computing power, it makes the idea of creating convincing simulated worlds seem less fantastical. If we're heading towards being able to do it, maybe someone else already did.
So our tech trajectory makes the premise more conceivable.
From our perspective, yes. Your sources mentioned things like OpenAI's work, Jony Ive getting involved in physical AI, integrating AI into the real world, and then there's brain-computer interfaces, BCIs.
Neuralink, Muse headbands.
Yeah. Their stated goals go beyond just fixing problems. They talk about expanding how we experience the world. And the speculation is there could BCIs eventually create seamless virtual realities, maybe even allow consciousness uploading.
So we're developing the kinds of tools that Bostrom's argument assumes future simulators would have.
We seem to be on that path, yes. We're building technologies that could potentially create simulations or profoundly alter our interaction with reality. It gives a kind of potential mechanism to these ideas.
It brings these huge philosophical questions down to earth a bit, thinking about the tech we're building right now.
It really does. It connects the ancient questions with our immediate future.
Okay. Wow. So we started with your really imaginative questions, pictures of aliens, living in other dimensions, the universe as a creature, and this deep dive following your sources has taken us through astrobiology's search.
To the bizarre possibilities of theoretical physics, like hidden dimensions and multiverses.
Connected to ancient philosophy about a living cosmos.
And landed on the modern simulation hypothesis, fueled by our own accelerating technology.
Yeah, and a theme that really seems to run through all of this, based on the sources, is this human fascination with unseen reality.
Absolutely. From invisible chemicals in space, to tiny curled up dimensions, to parallel shadow matter, to the possibility we're in a simulation layer, we can't perceive. It's all about probing beyond our immediate senses.
It shows that your questions, even if they sound fantastical, are actually touching on some of the biggest, deepest inquiries humans have. That curiosity drives science and philosophy.
And the fact that we don't have definitive proof for many of these things right now, well, that mainly tells us about the limits of our current technology and maybe even our perception. It doesn't mean the questions aren't valid.
Which leads back to that point about the lines blurring between science, philosophy, and tech. Things like AI and BCIs aren't just tools anymore.
They're potentially changing our ability to perceive reality, maybe even to create new realities or experiences. The work at OpenAI, the goals of BCI companies, it shows this convergence happening right now.
It feels like you can't really understand one without considering the others anymore.
Increasingly so, yes.
Okay, so maybe a final thought to leave you with, building right off that convergence point in the sources. Given that our own tech, especially AI and brain-computer interfaces, is pushing towards augmenting our senses, building virtual worlds, maybe even changing consciousness itself, what about our future? How might future humans, using these tools, start to perceive or even interact with aspects of reality, maybe even new dimensions or universes that are totally invisible and unimaginable to us right now?